on this one. Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith as ever here, and we've got one of my kind of least favourite jobs on the bench today. I may not even take it on, I'm just going to have a look at it. It's a Sunn 300T, and on the back it says model PR347. I've never seen one, but I know these Sunns are great big beasts of an amp, and this is a 150 watt amp with no less than 6550 valves in it to produce the 150 watt output. The reason I'm loath to take this on is because it's been not used for many years, and many years ago it was blowing fuses, not the mains fuse, some fuse on the board somewhere, and another technician had a look at it and said it might be the output transformer. So I thought I'd just give it the once over, and if nothing else I can let the client know that he should scrap it or maybe find somebody else to do it. Anyway, let's have a quick look top side and then we'll have a look underside and see if we can see what's going on with this amp. There are no valves with it at the moment. Okay, here we are top side. You might not be able to see, but it's sort of thick with dust really. No valves in any of these, all empty. All the 6550s have been taken out, all 6 of them. Look, 2, 3, 4, 5, 6. These 150 watt amps are really nasty. I've worked on some SVTs as well, and I just really dislike them. One problem with them, you can't move them. This took every ounce of my, I must admit, not considerable physical strength to lift this up on the bench. I can barely even lift one corner of it. So just flipping this over and getting it up on the bench is going to be, you know, a bit of a challenge. Anyway, so you can see what's happened here. All the valves have been taken out. I think it's probably someone's taped these down to just stop them rattling around. It hasn't been very successful, but anyway. Right, not much we can tell from this side. Let's have a look at the front panel. There it is there. Power, master volume. All very fancy. Graphic equalizer. They all seem to move okay. All these notches and things. All this means extra circuitry. Loads more stuff to go wrong. Standard channel select, and it's just got too much stuff on it basically. The pots feel not too bad actually. They're not seized or anything, considering it's been sitting around for a long time. They feel quite normal. They will be very dirty, of course, and need cleaning, but they don't feel seized, so that's good. Right, I haven't had a look underneath it yet. I'm just going to get the winch from the local garage and get a sky hook up on the ceiling, a block and tackle, and in a few hours' time we'll have this beauty upside down on the bench so that we can have a look underside. Oh my god, what a complete flipping nightmare this is. Look at this, a vast acreage of printed circuit board here, just goes on into the distance. Loads of soldered down chips. If ever you wanted to change a single component on this board, you're looking at hours of work to unplug all these connectors, somehow get the board out and upside down. It's just not workable on. What have we got here? Here's the valve board, look, the main power valve board. And he said that the fuses near the power valves were blowing. Well, I'm guessing that he means these fuses here. I wonder why there are only 3 of them, or why there are 3 of them. Curious number that. I would expect 6, 1 for each valve, or 3, 1 for each pair. That's a bit weird because you've got 3 working against 3 in this. Don't know. Let's have a look. This one, they all come up to the board here. All 3 of these fuses come up to the board here. This is the HT, obviously the HT caps. Right, I need to have a think about whether I even want to do anything with this in terms of powering it up or having a go at anything. I imagine the previous technician did what I did here and said, no thanks mate, could be the output transformer. I think I might do the same. Fuses everywhere. I think I'll check a few fuses just to see if these have all gone as they said, or whether these have gone or whatever. It might also be worth a no valve power up, just to see if we've got any HT on any of these pins here. In other words, a quick sort of 15-20 minute check over. Let's just do a few quick fuse checks. So there's this one here. Either the fuse has been removed or that's blown. This one here, that's intact. This one here, that's intact. Let's just double check this one. Right, so that fuse has gone. So we can replace that. What about this? That's okay. And these two, yep. And that one, okay, good. Right, well, what is this? Well, is there a fuse even in here? Yes, there is, and it's very much blown, as you can see. This might have only been blowing one fuse here. That's interesting. It's a very low value fuse. That's a 100 milliamp time delay. That is a suspiciously low value fuse. Do you know what? I don't even believe that that's correct. Why would you have a 100 milliamp fuse in a high power amp valve pair? I'm just going to check. These are all loose, these fuse holders too. Just going to check this one. I bet you this isn't 100 milliamps. It is though. That's 100 milliamps. Okay. That is a tiny fuse. I mean, 50 milliamps per valve would be nothing for an amp like this. What's this? Just check this one too. Check the third one, just in case they put the wrong value fuses in here. This is 100 milliamps, so these are all time delay 100 milliamp fuses. Huh. Now the problem is here, we don't know the provenance of this, which is why I don't like taking on amps that someone else has had a look at, or it has been blowing fuses for some considerable length of time. If it's been blowing fuses, someone's been replacing fuses. What have they been replacing them with? Are they 100 milliamp fuses supposed to be in there? I find it almost inconceivable. I've been wrong many times before, but that seems like an absolutely tiny fuse to me. I think I couldn't really proceed with this amp without confirming to myself what value that fuse is, because if this has been blowing fuses, and he did say it's these fuses here, the ones nearest the power valve, and let's say the first time it blew a fuse, I don't know, maybe due to a faulty valve or something, someone put the wrong fuse in, so instead of a T1 amp or whatever they put in a 100 milliamp, then everyone's just going to repeat that mistake, and it keeps blowing fuses. Well, of course it will, because the fuse is too small. I could be wrong. It could require a 100 milliamp fuse. In order to confirm that, I would have to check the actual schematic for this. The other thing I might try and do is find out where these wires here go. They obviously disappear under the board and go to the power valve somewhere. If I can find out what pin that's on, that might help me work out what that fuse is actually doing. Okay, follow me through on this. When you hear a beep, it's the fact that this is a short circuit, although it's not quite a short circuit. So from this side of the fuse, it's coming to this pin here. Well, it's not short circuit, it's 40 ohms or something, so that's a bit of a mystery. And it's also going to that pin there, the same thing, 40 ohms. So it's kind of as we suspected, this is doing one pair of valves here. There's this mysterious thing here which looks like a transistor, those three legs. So what that is, I don't know. And that is in between these two pins here. So that's a little bit concerning. Okay, so watch this one over here. You'd expect to have the same thing. So here, nothing on that pin. Here, we have exactly the same 40 ohms on this pin here. But not on this pin here. So that is just completely open circuit there, so I'm not quite sure what's happening between here and here. And then we'd expect the same here. Look on, can you see that? Yes, you can. So here, on that pin there, yep, 40 ohms. And on that pin there, we have 40 ohms. And there's that sort of funny transistor, or whatever it is, that three-legged thing in the middle there, of those two. We don't have that in the middle of these two. There isn't a three-legged, whatever this thing is, joining this to here. There's this, whatever this, I don't know what that is. So it's not kind of symmetrical. These two are quite symmetrical. That looks very much, this pair looks very much like this pair. This middle pair is similar, but not the same, so I'm not quite sure what's happening there. And unfortunately I don't really know, well, I suppose I could find out what pin this is. Not very easy. You won't believe how hard it is just to turn this over. You think, I'll just flip that over and have a look, see what that pin is, but it's weighs a ton. Okay, I managed to do that. Here are the spigots here, the keyway I should say, little keyways there. And I make this 1, 2, 3, I make this pin 4 here. So, I bet I know what this is. I bet these are the screen, pin 4 by the way is the screen. I bet these are the screen resistors here, 1 and 2, and this is the screen HT going off, feeding the two screen resistors. That would make sense. So these look like there might be fuses in the screens, in the screen supply somehow. Actually, that's a good idea. Let me see if there's a short circuit, proper short circuit from here to here. Yep. Yes, there is, about 7 ohms. So these resistors here are, I was measuring on here, but of course I'm measuring through the screen resistor now. There we go. That's 40 ohms. So these, that's quite low. Bit of a funny screen resistor, 40 ohms, but I guess it could be. So we'd expect to see screen resistors here, 40, 40. Screen resistors, I don't know where they are on here. Over here we have the same arrangement. So 40 ohms there, 40 ohms there. This is the one where we don't have, we have it on that pin, but we don't have it on this pin. That goes to here. Oh, this is probably, yeah, it's probably here. It looks probably upside down. So there's the screen resistor, there's the screen resistor, and there's the, yeah, and there's the feed. So this should go, this goes to pin 4, one side of the screen resistor. Yes, it is. That's a short circuit. This should go to pin 4. It does. So that's a short circuit, a literal short circuit. But this is a screen resistor here, and that screen resistor, look, is open circuit. So we have an open circuit screen resistor there. Weird value. It's amazing what you do topside, doesn't it, without a schematic. I took my eyes off it there. How annoying. Where is it? Oh yes, here we go. There. So there's an open circuit screen resistor. Actually, I'm now measuring 47 ohms on that. That's strange. What did that happen there? This comes into here. Short circuit it does. It should go by here, there to a 47 ohm. It is. And it should go by here to a 47 ohm, but it doesn't. Ah, yes it does, yep. It's just slightly more than 47 ohms, and it's not causing my continuity tester to beep. So that actually, take it all back, that is not an open circuit screen resistor. Right, I popped in another 100 milliamp fuse in there, so these are all now exactly the same and all the screen resistors are good. There are no valves in this, so I don't see any problem at all with powering this up and just having a little check around to see if we've got HT or anything like that. I'm going to do it on the variac, of course, because this hasn't been turned on for a number of years. I don't know how far I'm going to go with this. At the moment I'm playing. Right, we have it plugged in, and switched on, and I've checked that we have some AC voltage coming in at the main socket just to make sure it's all working and the amp is switched on properly. We'll take it, I think, out of standby. I think that's out of standby, and I've only got 40 volts going in, so I'm just going to turn this up a little bit and see if anything at all happens. In particular, we're looking for a bit of DC HT somewhere. I think this is a solid state rectifier. I'd be very surprised if it isn't, with all that power required. So let's just go to ground and pin 3, 1, 2, 3, nothing. Not sure which way around the standby switch is. Okay, nothing at all there. That's interesting. Oh yes, there's the 4 rectifier diodes just there, so it is a solid state rectifier. Absolutely nada in the way of DC here. Let's turn it up a little bit more. This has got a kind of blown fuse feel to it to me, but we've checked all the fuses. Oh, some hefty diodes here too. These are probably the HT diodes here. These will be doing low volts, low voltage, plus and minus 15 or something probably, who knows. Okay, turn off. Just check that the switch. I tell you what I haven't checked the mains fuse. Let me check that now. The actual, right, okay, there we go. So the mains fuse has gone as well. Right, what is this little beast? That's 100 milliamps, I'm going home. Expect it to be at least an amp. 6.3 amps, yeah! That's what I call a fuse. So we'll put another 6.3 amp fuse in there, and then we'll try that whole thing again. Okay, let's try that exercise again. And we'll turn on the variac. Variac's turned down to nothing. And we'll bring it up to have about 50 volts. And even at 50 volts, I'd expect to be seeing DC around the place. So let's just try here since we're here. Good, look, we've got 50 volts DC across there. So this is, the HT is coming up nicely, so that's good. So let's just go on to ground and see if we've got anything on pin 3 there. No. Surprising. Minus, there's a what's it there, the bias. 1, 2, 3, 4, 5, yeah, that's correct, the bias is there, look. Now, 1, 2, 3, there. Nothing on pin 3. Just check the other pin 3s. No. 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 No HT. I think we can safely bring this up a little bit more to 100 volts. Don't know what's going on here. This is kind of HT as well. We've got these big ones here are HT caps, and so are these. So I don't know why we have. This is probably for the preamp side of things. This, look, and we've got HT there. Look, on the preamp side. It's low at the moment, of course. I've only got 100 volts going into the variac. So this, what have we got here? That's okay, 100 volts, and this should be interesting. Nothing there. Nothing across that capacitor. What about this one? No. So some of these HT caps have voltage across them. Some don't. I mean, there's a fuse there, but I thought I'd checked all the fuses. Let me just check. Yes, that fuse is good. Okay. Complicated amplifier this. We seem to have rectifier diodes all over the place. There are 4 here doing some bridge rectification. There are 8 big ones here which are probably doing the main HT. There are another 4 here doing some other HT, probably for the preamp side. This is probably the winding coming in for this section. So when we turn on 100 volts, this section is kind of working okay. I don't know why that one isn't working, but we've got DC across this, 128 volts DC, and across here. And we haven't got a sniff of HT anywhere else. In other words, up here we haven't got it. So one possibility is that there's another HT winding, and there are 2 HT windings on this grey twisted pair here, and another twisted pair up here somewhere, which give the main HT. I wonder if it's these here with these 2 fuses in, brown and brown. Let's go into AC, see if we've got anything here. Yeah, we've got a massive 15 volts there, great. Doesn't tell us anything really. That could be 15 volts, that is very low. I wonder, oh yes, here we go, we've got 2 reds here, look. They are always HT, I don't know why they do that. It's very useful though. But on an amplifier, the 2 red windings, secondary windings, are usually HT. Okay, we have, friends, nothing on there. Now is the HT, okay, I think I know what's wrong. I think the amp is in standby. So let me turn it on. It's confusing, the standby switch, which direction, which way round it is. Now do we have any HT here? Any AC HT? We do. Oh good, okay, so we're slightly back in business now. Right, let's go back to DC and see if we have any HT here. 1, 2, 3. Yes we do, great. This will have an insanely high HT would be my guess. It's 200 volts with 66 volts going in. It's probably going to be 600 volts or something on here. Right, let's whack this up a bit. We've got no valves in, so I'm sort of fairly happy to do this. Up to 400 volts HT. Good. 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 Okay. So the HT is there. Do we have it here now? Yes, it's there as well now. So all this has come to life by turning the HT switch on. Right, so full power. And let's check out what crazy HT we have. 770 volts HT. Madness. How are they coping with that in terms of capacitance? Because these are only 500 volt caps. 450 volts actually. They must be putting them in series, but I would expect to see an even number of caps. Whew, 700 volts. I'm not getting anywhere near this. 770 volts. I told you it was insane, didn't I? I don't like working on these amps. I really, really don't. This is kill you stone dead time. Just touch that and you're finished. Right, well, okay, well the HT's alright on all the power valves. Let's just check on the preamp valves. Pin 1 and 6 maybe. Yeah, that's got 380 volts, 140. They're all okay. How about this one? Yeah, that's okay. Right, so the next thing, if I'm going to do anything at all, I'm going to put some preamp valves in. Turn that off first of all. Now we have to be very careful here. I've turned this off. There's nothing to drain the HT. No valves in there, so watch this. Amps off. 550 volts, look. And slowly falling. That's already way above a Marshall HT, 470 volts, and it will come down. But you have to be very careful. If the valves are in and on, and the standby switch is on, when you turn the power off, the valves will quickly drain the HT. Obviously if the standby switch is off, they won't. Okay, we put 4 new JJ ECC83s in. I fully expect this to turn on with no problems whatsoever, and for those valves to light up. I think the problem is going to be on the power side. The plan there is if we get this far with it, I'm going to put 2 valves in. I'm going to put this pair in here. I need to have a think about which valves actually. 2, 3, 3 pairs, okay. Ah, look, there's a fuse written on the back there. It says T100 milliamps. Yes, a question of which. It's a funny amp, this actually. I'm not quite sure what's going on here. They've arranged these valves in pairs. Look, there's a pair there with some kind of light probably that tells you they're okay or something, I don't know. Another pair there. And a third pair here. You've got 3 pairs of valves, but you actually want 2 triplets of valves pushing and pulling on a 150 watt amp. You've got these 3 fuses. Very strange arrangement, that. Anyway, I intend to put, I think I'll probably just put the outside pair of valves in on bias meters and see what's going on. Anyway, for the moment, let's turn this on the variac and wind it up, although I don't expect any issues at all here. Right, that's on full power. There are no lights on the front of this amp, which is not even a power light. Ah, I know why. In order to get power to an amplifier, here's a little workshop tip for you. It's always handy to plug this thing here into the back. That's what delivers the power to the amp. So if you've got a dead amp and this is just hanging around on the bench like this, check this out first. Try again. Right, turn it up. Yeah, we've got some dim lights. Yeah, we've got lights on the front, that's good. That kind of shows us that things like, you know, the plus and minus 15 volts and all that kind of stuff are probably working. Right, channel select. Yeah, channel select works on the front as well, so that's good. Full power. Oh, we've got some green, pretty green lights here. Now, I would normally take that to mean everything's good. But there are no valves in here, so I don't know. Anyway, all I'm looking for at the moment is for these valves to glow. They are glowing. And so I think the preamp side is okay. Right, the next thing to do is get 2 valves in here. One of them on a bias meter. Actually, I think I might put 2 of them on a bias meter. And then just gradually wind this thing up and see what's happening. I mean, yeah, that technician could have been right. The output transformer could have gone. Yeah, in which case we're in real trouble. So let's get that set up. The 6550 is one of the highest power valves you can get for these sort of amplifiers, and they are beasts of valves. By the way, one reason that a screen resistor might go, or a screen fuse in this particular case, is if the anode voltage, the plate voltage, isn't present, but the screen plate voltage is. And that causes all the current to go out the screen, because the plate is not positive. So that hardly takes any current going out the screen to blow the screen resistor or the fuse in this case. So that could be one issue. But we measured the HT was okay on pin 3, so anyway, these meters will tell us whether HT is present as well. So there we go, we're all set up. I have no idea what's going to happen here, to be honest with you. There's obviously something wrong with this amp. I mean, it's hard to believe it was just a valve and they just kept, you know, blowing fuses. Anyway, we can start checking gradually by bringing this up on the variac. So there's 50 volts there. These probably won't start coming to life for about now. Needs a bit. They pull their voltage off of here, of course. So right, there we go. We've got 430 volts HT, and I'm not drawing much current yet, or on this one. That's because the valves are cold. So I want to watch what happens here. I'd like to see this HT creeping up as the valves warm up. We've only got 100 volts going in at the moment, so the heaters won't be very hot. 100 volts in, look, and we've got 500 volts HT. It's mad. You won't be able to see this meter here. It's virtually unreadable by me, and you won't be able to pick it up on the camera. Right, I'm going to edge this up a little bit. We've got 130 volts going in now, so I'd expect the heaters to be kicking in. These have all gone red, but I don't know what that means really. Well, there's no current being pulled by these valves currently. But we do have HT on them. Ah, is this one coming up a bit? Yes, it is. This one's pulling a bit of current. I'm just going to edge this up a little bit. Aha, right, this is looking promising, and so's this one. Right, these valves are pulling current. Good. I'm going to keep it low for the moment. That's just a couple of milliamps current being pulled through these valves. That's good. Do you know what? I'm just going to plug a speaker into this and see if I can hear anything. Right, not a peep out of the speaker, not even a little tiny sniff, and I'd expect to hear something even with 3 milliamps going through these. And let's edge this up a bit. We're okay with 20 milliamps or something going through here. Nothing coming out of the speaker though. That's absolutely dead, the speaker. Now if of course the output transformer, which is here, had an open circuit secondary, I'd find that a bit hard to believe, having an open circuit secondary. If it had an open circuit primary, we wouldn't be getting any HT on our valves. Anyway, we're not blowing any screen fuses or anything. These are all nice and stable. Full power there, look. And we've got crazy HT. Only 18 milliamps and 14 on this one, so they're warm. We should definitely be hearing something now. Quite literally nothing coming out the speaker. That's a little bit weird, that. Right. Oh, that's interesting. The valves have gone green, look. Showing they're in the kind of correct bias range. So everything's okay on this at the moment, with the exception of the fact that there's nothing whatsoever coming out the speaker. Well, let me make absolutely sure I'm plugged into the right speaker socket. I'm 99% sure I am. Yep, there's a big green piece of tape here with an arrow on it pointing to here, and it says main speaker. Well, I put my ear very close to the speaker and I could hear a little buzz. And when I unplugged the speaker jack plug and put it back in again, I could hear a change. So I'm just now going to try the effects send and return loop here. And oh, that's interesting. Oh, look at that. So going into the effects return gives us a signal. Well, that's awesome. This amp is basically working, sort of. So this is the guitar coming back in through the effects return. Excuse the buzz, it's because the guitar's close to the amp. Right, why the front end is not working, I don't know. I thought it might be the effects loop dirty jacks, but I've bypassed it. And still nothing. Channel selection's all working. Volumes are all up. Master volume's up. Gain's up. All this logic's working fine here. Pressing these buttons and it all looks good, but there's nothing coming in at the front end. Oh, it's there, quite distorted. You can just about hear it. Okay, that is to be investigated. I think, what's the next thing to do? I think the only thing we can now do, you know, is to bring these two valves in to the next position. I'd like to prove that all positions here are okay. Okay, I've bought exactly the same pair in one position. I just want to check that all these positions are okay. I'm going to put it on the variac this time, and just bring it up again. Okay, the valves are warm, so it shouldn't take too long for them to. 400 volts HT and 17 milliamps, which is kind of okay, but as I increase, forget this one for the moment, this is showing nothing. There's absolutely no current going through that. As I increase the voltage, it suddenly drops down to nothing. Ooh. As I decrease the voltage, it goes up high. This is a very strange effect. I don't know what's happening here. So we've got no current at all on this one. 0. And this one, the current disappears as I turn it up, and gets very high down there. Get a very high current there, and then I don't like this at all. Okay, I think I want to go back to this position here and just check that we're still all okay there. These are behaving very strangely. I'm also going to have to, I think, make a note here of what's going on. I thought I'd just quickly check out the middle position, see what's going on there. Okay, we're on 50 volts. Can't really do anything until these come to life, because they require a certain voltage to come to life. Right, there's the HT. And there's a bit of current there, 1 milliamp. No current on this one yet. Let's increase the HT a bit. We're only 120 volts going in. No current on this one yet. Hmm, 150 volts going in. And no current on this one or this one. Or this one. What's going on? Okay, it's starting to come to life now with a bit more power. Bit of an ominous hum I haven't really noticed before. Oh, that's coming out of the speaker. Okay, so this has got this seems to be coming up okay. I'll just go a bit higher. 12 milliamps and this is 10 milliamps, so these are okay. Full power, and it's 18 milliamps and 15 milliamps, so these two seem okay. .730 volts HT. That's strange. Okay, well let's go back to the outside ones. Okay, we're on the outside positions again. I just want to check that they are doing what they should be doing. Current's coming up on this one and on this one. 3 milliamps. Full power, 10 milliamps. 12, 13, yep, so these are okay. It was just this position here which seemed to be wrong. Plus the fact, of course, we've got no input. This is still working here on the effects loop, but just a very, very low level distorted signal coming through the main channel. Okay, we've got 20 milliamps here, 16 there, that's okay. Let's go back to this faulty position and just double check that. Okay, here we are again in this position here, and well, we are off at the moment. Turn it on. This is behaving oddly. As I go up, nothing happens here. There's nothing there whatsoever. And when I go down in voltage, it suddenly leaps up to huge current. This one here, you won't be able to see it. It's got 531 volts HT. No current whatsoever. Oh, now hang on full power. Let's just put this on full power. Ah, this is coming up now. Maybe it's something to do with the meter not liking the lower current. Okay, I'm happy about that. I couldn't really think my two positions would be weird. Oh, that's good. Okay, so these are both 15 milliamps too. As soon as I give them full power, full HT. Alright, so these are all identical now, which is great. So my view is that we have tried all 6 positions with 2 known good valves, and basically they're all good. We haven't blown any fuses. There's the most tiny, quite distorted signal coming out of the loudspeaker. And that's the same. Right, well, there's nothing for it now apart from to flip it over again. Well, it's interesting that the power section seems to be okay, whereas that was what was causing the problem. And it's the preamp section now that's the problem, but you can see the issue we have here, and I don't really know how far to go with this, or even if I can even begin to make a start on it. You know, we've got standard 12x7 input stages here. We could put a scope on there, see if the signal's getting through. But then, you know, we've just got dozens and dozens of op amps. So there's 3 there. There's a load over here. There's, you know, quad op amps. We can check that the plus and minus 15 is getting there, because that would definitely cause a problem if it wasn't. Load more here. Look, multi-pin 20-pin chips down here. In there, even if you diagnosed that the dual op amp was down or something, what on earth are you going to do about it? You know, I suppose you might be able to chop it out and do a topside repair, but you're looking at a vast amount of work just to think about taking this board out and flipping it upside down to change one component. Anyway, I'm a little bit disappointed because you know, the power section is working okay now. And that seemed to be the problem. It was blowing fuses. We didn't hear anything about a preamp side problem. So all I think I will do now, I'm going to call it a night now. I'm just going to turn off, and I will put a signal in here, a tone, and then we'll see if we've got anything on pins 1 and 6 of these preamp valves. That'll be a start at least. Okay, so I've had to think about this amp, and there's a limit to what I'm prepared to do on it. To be totally honest with you, it's not worth a lot. I don't know, £500 or something. Bottom line is nobody wants them. They're huge, hulking beasts of an amp. You can't pick it up. It's got £300 worth of valves on it, all for the sake of getting an extra 50 watts. So it's a complete disaster, really. I can't imagine why anyone would want to own this amp, and indeed they don't. They don't go for very much money. So that, coupled with the fact that it's nightmarishly difficult to sort anything out on this, I don't want to run up a big bill for the customer only to say, yep, sorry, please give me £150, and I didn't get anywhere at all with your amp. It goes with the territory doing this job. You have to take a view on things. And although I'm not strictly doing it for the money, in that I don't have to earn a living from it, it still needs to be a kind of commercially viable deal. Right, so with that preamble, what I'm just going to do is I want to check these early input stages. And the first thing I'm going to do is make sure we've got HT on pins 1. It's a bit low, that, 133 volts. Not quite sure why. On V1, 2, 3, 4, 5, 6, and again 130 volts. I'd have expected 230 volts, but who knows. But even with that on, we'd certainly hear something. Now let me check on V2, so pin 1. Now that's interesting. Now, let me just backtrack. As I touch on here, there's nothing at all. I can't hear any buzz from the speaker or anything, which you definitely would do if this stage was live. But nothing there at all. However, when I go on here, you won't be able to hear it, but I hear a definite kind of live buzz there. So again, we've got 138 volts there, which is on the low side. 2, 3, 4, 5, 6, 161 volts there. This 100k is almost certainly the anode resistor, the plate resistor for this. Let's see what the HT is here. So it's 220 volts on the HT, going down to 137 volts. I thought that was on the low side, the HT there, but anyway, here's another 100k resistor here, and we've got 220 volts HT, 130. So both of these valves are in a similar sort of kind of a state. Both on, they're both drawing current, and this one's live. Buzz, buzz, buzz. I bet if I injected a signal in there, we would hear something coming out the amp. I might even do that. There's nothing on pin 6 though, but I don't know what they're doing with this amp. It might even just be using one half of this valve here. So this front end here is very, very dead. Let me go on to the grid of this valve here and see if we hear anything. Okay, the grids are pins 2 and 7, so totally dead as a doornail. Nothing there. Nothing there at all that I can hear coming through. How about the same here? Yeah, buzz, buzz, buzz. But nothing on that one. So it's looking like it's kind of this stage here. Check this. Yes, that's the HT cap, 220 volts there. Again, yeah, that does feel on the low side, but I don't really know what they're putting on these preamp valves. But even that lowish voltage, I think we would hear something. Right. So the next thing to do, I've got a tone going into the amp, by the way. Just turned it on. And it's there, but very low level and distorted. It's kind of almost like there's a mute switch or something. Just checking the volumes, making sure I'm not doing anything stupid here, like, you know, when I go onto channel 1, that tone goes even lower level. Everything's kind of up full here. Sure it's not. Aha! Goody goody! Ooh, I like that. Right, my friends. What we have here is a little tiny button up the top left here called Tuner Only. It's kind of that way. And that was pushed in, so that's a little danger zone there. So I guess you can put a tuner in the back or something, and that was pressed in. So that's why we haven't got any signal. Well, that is good news. So I'm going to take out the tone from the input channel and plug a guitar in. I must admit I'm quite pleased with my instincts there. It felt like there was a mute switch in or something, but I've looked 2 or 3 times for a mute switch, which of course I'd expect to find on the front end. I didn't expect to look right across the other side of the amp, which is where it is, completely by the master volume, and there's a little tiny button marked Tuner Only. Anyway, there you go. Right, I'm going to turn this lot down a bit. Now we have a reassuring buzz. That's working. Okay, that's good. Scratchy pots here. Hey, this is looking promising, folks. Too many controls on this. We've got compressor gain, we've got compressor EQ balance, we've got all sorts of buttons and knobs. There are 4 underneath the EQ alone. I really hate this kind of thing. Just way too complicated. But the good news is this is actually flipping all working, would you believe? And the bias is looking good. You can't see it, it's 20 milliamps on each valve, each of those pair. I don't know if that's right or not, we can check that. And we have sounds pretty good, I have to say. Whoa. Well, that's rather amazing. Okay.